AWS Networking Part 2. In the previous episode, Part 1, we have described the hierarchy of the basic network in AWS, which is composed out of VPC, then availability zones, and we also have the subnets in the availability zones, and we have the routing. So the subnets is what defines the range of the networks for each availability zone. The VPC itself has an IP range, and the subnets are derived. The subnets range IP addresses is a subset of the VPC IP addresses, and all these IPs are internal IPs that you would not find in any public IP, for example 172.31.continued. The routing and the routing tables is what defines for the packets how to move from one machine to another, where to go, the route. And by default, it contains the internal routing, which would allow the packets to arrive to internal machines. And now the question is how to communicate with the external internet, because so far in part 1, we described internal communications. So for external communication, we need obviously a public IP such that external hosts would be able to contact us. We also need to have the proper routing. So if we try to contact an IP that exists in the public internet, then the routing will enable us and let the packet know where to go. And also we need to be able to control what would happen to external packets, how they would reach our internet, and to be able to differ between situations where we have both in and outgoing traffic. If we have a web server, we want both in traffic and outgoing traffic. But if all we want is to access to internet in order to download some patches, then we only want outbound traffic. Okay, so the first part is to be able to define a public IP address. And in the VPC, we now define a public subnet. So up until now, we have only defined private subnets. So now we go to the VPC and define a public subnet. Why public? Because we are going to be given a public IP on this public subnet. So we had the VPC. Under the VPC, we had availability zones. And now under the VPC, we defined a public subnet, and we are given a public IP address. Great. So now we have a public IP where external components from the internet can contact us. The next step is to be able to have both the inbound and the outbound communication. IP is not enough. IP is something virtual that we assign to something. So we assign this IP to the new component that we are going to define, which is named Internet Gateway, IGW. So we go again to the AWS console and create an Internet Gateway that would receive this public IP. And this public IP can be something like 198.51.10.0.3, something general that exists, a general public IP. And this now Internet Gateway would be able to connect from the internet to us, and we would be able to connect to it. In order to be able to connect to it, then each host, when it's going to an external IP, needs to know to connect to the Internet Gateway. So we need to define in the routing table, again, what defines for the packets where to go, to define that the public address 0.0.0.0 would go through the Internet Gateway, both for inbound and for outbound traffic. So this is how we connect to the public internet. Now for the specific use case where we want only inbound traffic, where we want only outbound traffic in order to download software and download patches, and we are not actually having a web host. Then we need to create not an internet gateway, but a NAT gateway. And the NAT gateway is something that allows only for one-way communication. So in our example, we had the one-way communication from our cluster, from our internal network into the internet in order to download software and patches. So these were the components: the public IP, the routing table, a public subnet that we define in the VPC, public IP, the internet gateway, the routing where we need to define and to connect the internet gateway, and the NAT gateway.